Okay, we're going to do the expected time here in sheet 2. Okay, so first we have to enter the optimistic time, most likely time, and pessimistic time, and they are given to us here, and we already saw this in the PowerPoint file. Okay, so let's enter those first right here. Okay, so then expected time is A plus 4m plus b, all right, so the whole thing divided by 6. So that gives us the expected time. So let's enter that, copy that down up to here. So I'll put the bottom border back. Okay, and the variance is b. Okay. The variance is b minus a. Okay, we can square this and divide by 36. Okay, or if you want to divide and then square, we can do it that way too. Okay, so that's our variance. Okay, copy that. So now we have the expected time and variance for each activity. So right now we need the expected time. We'll use variance a little in a little bit. Okay, so now we can enter these expected times into our network. So first I'm going to copy paste the network that we created in sheet 1. So let's start from here and highlight all of that. Control C for copy. All right, so I'm going to put it starting from C8. Okay, so now we have the network. So let me reduce the zoom. Now let's go ahead and enter. So the third row, okay, we already left room for entering the activity times. That's where we will enter the activity time. So expected activity time. So that will be, I'm going to use cell reference formulas like that, not enter the value 2. Okay, so that's that. For B, it is that. For C, it is that. So I'll be looking for this. You should not just type the value. So you must use cell reference addresses like this, because if for some reason there was a typo somewhere and you have to go and correct it, and all of the other values will be automatically updated if you do it in this fashion. If you just type and type in the values, then you have to go back and search which cells are affected, and you have to correct them manually, which is not a good idea. Okay, so that's F37, and that is F36. G is that, and finally that. Okay, so now we have the time estimates entered into the network. So the next step is to find the critical path, and there are a couple of ways in which this can be done. Okay, the one way is to enumerate all the paths in the network from start to finish. Okay, so this part is not in your textbook, but it is a good idea to look at all the paths. So here we have, so starting from here, so A, C, F, and H, and finish. So A, C, F, and H. Okay, so that is one path. And then we have A, C, E, G, H, and finish. So we have A, C, E, G, and H. All right. Okay, so that exhausts all the possible paths through A, and through B we have B, D, G, and H. B, D, G, and H. All right. So that's it. There are no more paths. Now if we can find the duration, total duration of each path, then from that we can find what the duration of the project will be. So we need to find the path time. So path time for ACF is 2 plus 2, 4 plus 3, 7 plus 2, 9. Okay, so instead of doing this manually, prone to mistakes, what I'm going to do is to set up the paths here and use sum product with the expected time to find the path time. So let's first get these paths over here, and I'm going to use transpose to get these paths in the label right there. So highlight like that, and then do transpose these three, close parenthesis. Remember, transpose is an array function, so control shift, press control shift, keep the two keys control and shift depressed, and then press enter. So we have that. So now let's put ones for the activities in the path A, C, F, and H. Then A, C, E, G, and H, B, D, G, and H. Okay, so let's center them properly. All right. So now the path time then is some product, okay, of the expected times, and make that absolute reference so that this formula can be copied. Okay, that with this range. Okay, so this will then, wherever there is a blank, the expected time will get multiplied by 0. So where there is a 1, then the expected time will be multiplied by 1 and added up. So now that will give us the path time. Okay, we'll get to variance. So we can do variance the same way. Sum product. Okay. So variance, make sure that it is absolute referenced. Okay, and then that. So that will give us the variance of that path. Center that. So now copy these two that way. Then we have the path duration for each of the three paths, and we want these to come here. Once again, we can do a transpose. Okay, we can do two columns at the same time. So transpose that, close parenthesis, control shift enter. So that gives us the path time and variance for each of these paths. The longest path, okay, let's put the border back. So the longest path is the critical path. So the critical path here is that one. So critical path is A, C, E G H, and the project completion time is 15.